Good morning. Sound check. You can, interpreters, can you hear me okay? All right, great. Good morning. My name is Nishal Goburdhan, and I work at Packet Clearinghouse. And welcome to CA Proof 3. I'm excited to be here. It's my second trip to Bishkek. Not doing anything technical this time. And thank you to the RIPE NCC for inviting me to do this opening session again. If you've attended any one of the earlier Central Asia Clearing Forum meetings, then you probably would have heard most of what I'm going to tell you. I see some newcomers in the room. I apologize to those people that have been here before. But as Vahan said, there's some really important concepts that I hope we can go through today. And I hope if you've listened to me before, then you've had a year to think about questions, and that there'll be lots of questions at the end of this. But yeah, this is the newcomer session. And the goal here is really to try to give you an idea of what we want to do. Why are we trying to build this peering forum? What is the outcome? What's the goal that we're looking at getting? Or why does peering matter? And the second part of this is to get you to understand how to use the tools and how to use the meeting to further that aim, to make peering work better for you. I hope this is useful to you. I did this off a machine translator, so I hope it says the right thing. I promise you, I'm not trying to sell you anything. I don't work for somebody who is going to tell you, buy this box, because that's not what I'm here to talk to you about today. What I want you to do is to understand the message that I'm telling you, because the message that I'm telling you, hopefully, is going to change the way you think about interconnections. And if it does, it's going to change the way you think about building infrastructure and growing this part of the world. So as Vahan mentioned, I work at Packet Clearinghouse. We're actually not that very well known unless you work in the deep, dark corners of the internet. You don't really know about us. We're more a back-end organization that does support for a lot of the critical internet infrastructure that you might hear about. We spend a lot of our time talking to people about how to build resilient systems, how to build and scale the DNS, helping with exchange point development builds across the world. I work out of Johannesburg, South Africa, so my apologies. I know very, very few Russian words and even few Kyrgyz words. This is an old picture. For those of you that have been around the internet for a while, you may recognize it. It's the last updated version that I know of a view of what the internet looks like from kaida.org. And while this is heavily descriptive for the technical folk here, it's really not so useful when we have to look at the internet or try to understand the internet as somebody who's approaching it for the first time. So I prefer to think of it like this. This is traditionally how internet networks were built. We used to have, if you want to call it, 3 sets of internet service providers. We would have a local ISP, and a local ISP is somebody that operates within a particular region or within a particular city, or sometimes even within just a single country. We would then have regional ISPs, and regional ISPs are larger internet service providers that service more than one city, perhaps more than one country, or more than one city. And then we would have global or first-tier internet service providers. And these are the largest of the large. And they are the ones that build networks that span the globe. There's about 14 of them, if I remember correctly now. And it's really, really difficult to get into this club. And the way that internet traffic has flown since time immemorial, ever since we've made the internet this non-commercial, ever since we've moved the internet away from the US NSF into this, is that the ISP at the bottom always buys internet transit from an ISP that's up one layer. And so the important thing here, we have a pointer. The important thing here is to remember the direction of the arrow. If you're at the bottom, if you're a local ISP, to get connected to the internet, you're giving money to the ISP that's in the middle, who is then giving money to one of the really big ISPs at the top, who is somehow connecting you to everyone else on the internet. But that arrow, that money, only flows in one direction. And that's what I want you to see here, because that money is your money, right? And the goal of this exercise should be, well, how do I save my money? If you're interested in knowing how to save money, well, that's what we're going to be talking about. So somewhere along the line, in about 1994, internet network operators at the mid-tier started to realize that we're just giving money to the big ISPs at the top. And all that the big ISPs at the top are doing are interconnecting themselves using those green lines. Well, why can't we do that ourselves? And that's what started to happen. And those pink, purple lines that we see in the middle, in about 1994, those lines started to happen. Interconnection started to happen at that mid-tier level, all right? And the interconnection worked. The internet didn't break. People, network operators, got braver. And they've built that interconnection into something that we call an internet exchange point. Starting in 1994, May East on the eastern coast of the United States of America was the first known internet exchange point, and it was the first time that internet operators got together and said, instead of just sending all of our traffic one level up, can't we start connecting locally? And so the concept of peering and interconnection was born. Let that sink in for a minute. That's 1994. That is a long time ago, right? That's 30 years ago. If the first internet exchange points date back to 30 years, how is it today that we still have many countries and many regions of the world that don't have working internet exchange points? But let's get back to our story. So everybody's interconnecting. And of course, not all networks are interconnected at the internet exchange point. So for the network on the extreme left, to get to the network on the extreme right, the packets are still going to go all the way up. They're still going to get to the provider at the edge. And you're still going to need the transit internet service provider that you had before. And this is a good time for us to introduce the concepts or the definitions for peering in transit, as I'd like to say. And the essential difference here is that transit, when you're paying an internet service provider for taking your packets and carrying your packets to one network away and then one network beyond them, that's a paid relationship, right? Nobody is going to do that for free. Whereas at an internet exchange point, if you're able to interconnect with other networks, then the other networks that you're connecting with don't charge you for the traffic exchange that happens across the internet, happens across that network, that peering point. So you may have to build infrastructure to get to an internet exchange point. That might cost you money. But for the actual traffic that's going across the internet exchange, there's no per megabit per second rate that you're paying. And that's the essential difference that you want to remember when you think about transit and peering, right? Transit has a fixed and usually decreasing, but always more eventually per megabit per second rate. But peering, you pay for a port cost perhaps at an exchange point, and thereafter everything is pretty much free of charge. Any model that you think about for moving traffic on the internet can fit into one of three ways. That is, if you can think about how traffic would move across the internet, there's only one of three ways that this can happen. And it's going to be this. So let's work through it together. In scenario one, we have a network, the green ISP network, and the green ISP network has two customers, a green customer on the left and a green customer on the right. The green customer on the left pays money to his internet service provider. the green customer on the right, also pays money to his internet service provider because we're saying, please connect us to the internet. And there's a fee attached to that, right? That's the transit fee that we're paying. At the end of the day, the green network is able to connect the two green customers. It earns $1 or a SOM or a euro, but it earns 1 unit from the customer on the left. It earns another unit for the customer on the right. And at the end of the day, it has earned 2 units, $2. Of course, it's not that simple. You have to pay for port costs. You have to pay some way to get infrastructure built, to get your customers connected. But we're talking about, this is a simplified model, and we're talking really about the costs of the traffic exchange. So the green network earns 2 units. In situation number 2, we've got a green network, we've got a red network, and the green customer wants to speak to the red customer. But they're not directly connected to each other. And the only way that they can get to talk to each other would have to be going through an internet transit network that's in the middle. I live very far away in Johannesburg. If you want to send something to me, this is probably how our traffic is going to move to each other. Your internet service provider via some sort of transit network operator to my internet service provider. In this scenario, the green network still earns $1 from its customer. The red network earns $1 from its customer. But because there's no direct connection, and it might be economically unfeasible, connecting Johannesburg, South Africa to Bishkek, Kyrgyzstan is probably not economically feasible. So because it's not economically feasible, we have a transit network in the middle. But that transit network doesn't do anything for free, so it's going to charge some value we're going to call that X. And at the end of the day, the networks, green and red, they're going to earn $1, but they're going to spend some value X on whatever it is that they are paying to their transit network. So your earnings as a network operator are 1 minus X. And the third model for traffic exchange is similar to this, but in the middle is an internet exchange point. Now, as we've already said, when you get connected to an exchange point, there's no fee for you to move traffic across the exchange point. So for the red network to speak to the green network, there's no additional cost per megabit per second that they're going to pay. They earn $1 from their customer. They spend nothing for the traffic exchange. So at the end of the day, their earnings are 1. Of the 3 situations, you've got a situation where you've got an earnings of 2, an earnings of 1 minus X, and an earning of 1. If you're profit maximizing, of course, you're going to tell me you want to be in situation or scenario number 1, because you want to earn 2 units, because who doesn't want the most money that they can make? But the reality is that that is a theoretical scenario. There's no network in the world that's big enough to span the entire world. Many have tried, they haven't made it out there. So earning 2 sounds nice, but it's theoretically impossible. So you're left with 2 options. And those options are, do you want to earn 1 unit? Or do you want to earn 1 minus whatever the transit cost is going to be? And if you remember nothing else from today, I ask you to remember that, because that's what it comes down to when you think about building and you think about where and how to interconnect. And that's, what do I want my earnings to be at the end of the day? So any rational internet network operator who's trying to maximize their earnings is also at the same time going to try to maximize the peering spread of the network. You got it? Okay, we're done. No, not quite. There's a few more things that I still want to work through with you, but more of the presentation to walk through. So how do we interconnect and where do we interconnect? Well, if we're always trying to reduce our spend, we're trying to maximize our earnings, then costs drive the way that we build networks. And what we've learned over 30 plus years of building the internet is that simplicity is the Simplicity is the best design criteria that we can have. Designing and building a simple network is what we want. So exchange points themselves are generally really, really simple networks. I run 4 internet exchange points in my country in my spare time because I can. It doesn't require me to be spending every single second looking at a screen or looking at a monitoring device, making sure things work. And we're not the largest exchanges in the world. We have, all in all, about 500 peers across the exchanges. That's not small either. But running an internet exchange isn't difficult, doesn't take a lot of time because we build it to be simple. We use cheap technology. In today's world, Ethernet has worn out. There have been many different types of internet exchanges, but if you're connecting to an internet exchange today, it is 100% going to be some kind of Ethernet-based fabric. And there's other advantages that we'll work through in a bit. So I said that there are regions in the world, or that there are countries in the world that still don't have internet exchanges. I work at PCH, and one of the things that we do is we've been running something called the Internet Exchange Directory, which lists all the internet exchanges for more than 25 years. And yes, you can see large parts of, oh, we've lost the pointer. Large parts of Northern Africa, a few countries in the Pacific, and parts of Central Asia still don't have internet exchanges. But the goal isn't about saying we need an internet exchange point per country, right? That's the wrong way to think about this. What we want to think about is where and how should we be building internet exchanges? And how do internet exchanges affect the way that we're spending money? We're still talking about that money thing, right? And we'll go through these, right? Because this is the value that internet exchanges bring you. They have to bring you cost reduction, because this is what I want you to remember. They'll bring you performance, lower latency. They're an economic tool, and I think that hopefully at the end of this talk, you'll see that. But today we also have newer restrictions around things like data sovereignty, things we didn't think about 30 years ago. And internet exchanges promote that agenda. If you're worried about data privacy, if you're worried about security, who here hasn't heard of Snowden, right? Things like local peering and exchanging traffic in your country become a lot more important. And finally, I think the thing that I like to talk about is how do we build our own knowledge economy? I mean, why am I talking to you? I'm some guy from South Africa that you've never met or heard of, and there's nothing that makes me special, except that I got into peering quite early, and I thought it was interesting. And now I get to do this. I get to travel the world and talk to people about why peering is important. But how do you build your generation, your next generation? And how do you grow your knowledge economy? What is it that you're looking to export to the world? I like to, or we often talk about, at PCH, we often talk about the internet as it's built from an ISP's perspective. Because I think, and aside from it just being ISP biased, I think it's a good way to understand, again, that economics that I want you to think towards. But first, I always like to ask this question: who here is interested in wanting to run some sort of cloud business? Because that's the word. Sorry, I should change this to AI, because that's the exciting thing today. So AI / cloud / if you're thinking of running some kind of VPS service, or if you're thinking of running some kind of virtual machine environment where you want to rent things out to people that want to buy your services, what would you charge in this region of the world? If you had to, let's say, rent a virtual machine for 1 core, 1 gig of RAM, a moderate amount of disk space, would it be $5? Would it be $10? Would it be $20? Well, last year when I asked this at CFF, the answer that I got was maybe about $20. And I said, well, at $20, you're probably not going to succeed when people compare you to what virtual machines cost in Frankfurt, in Amsterdam, in London. Because I looked it up last night, and you could get pretty much what I described, 20 gigs worth of SSD space for €5 a month in Amsterdam. So what's driving that cost? Why is it $20 here, but why is it $5 in Amsterdam? I like to do this in the currency of the country that I'm in, but because there's many of you here, I thought, let me use my currency instead. As I said, I'm South African. So ZAR, over a 10-year span, we've lost 35% the value of our currency to the United States dollar, right? So today, 1 rand is worth, well, whatever that small number is at the bottom, but I can tell you it's not worth a lot. Let me ask the question to you. Does this look familiar to you? If you're from Kyrgyzstan, if you're from Tajikistan, if you're from Kazakhstan, I looked up your currencies last night, right? The date and the time you can see is on the right-hand side. You look just like this. In fact, some of you look worse, I'm sad to say. Bear this in mind, right? Because what we're going to talk about is directly linked to this. Let's talk about how the internet would have started in most countries and how it probably still exists in some countries in this region still. Many, many years ago, the dawn of the internet, we had one internet service provider, and that one internet service provider was providing connectivity to probably the country. That internet service provider comes to the local market, spends money in the local market to get customers. So you reach out to a customer purchases a service from you, and they purchase a service paying in local currency, because no customer of yours today is going to be happy to pay dollars or euros or pounds. As an internet service provider, you go to the market, you collect all of these customers, and now that you have a customer base, right, you say, I need to connect you to the internet. And because there's no infrastructure in my country, the only way that I can get you connected to the internet is to go to an external transit provider. And that transit provider might be American, it might be Russian, it might be Chinese, it might be European, we don't care. But you're going to an internet service provider that is out of your country. And you are signing an agreement with them and saying, I will pay you money for probably 3 years. And for those 3 years, I want you to connect me to the internet. But the money that you're paying them is not in SOM. It's probably in dollars or euros or rubles or some external currency. You're transacting in your local market in local money, but when you're going to buy services from an external provider, you're paying in foreign currency. You're collecting customers, local money, going to an external provider, foreign money. And if that's all you're doing, then I have news for you. You're not an internet service provider. You're a currency exchange provider. That's what you are. Because that's the service that you're providing, right? You're getting money in, you're doing a little bit of packet changing, routing it to the internet, and then paying somebody else externally. And if that's how you're running your business, then this should be of extreme concern to you, because that's the trajectory that pretty much all of our currencies have been heading into. And well, I hope it's changing, but I'm a realist. And I know that that's going to take many, many years to fix. The second phase of this growth, change, build that we do when we build internet networks is to say, we've got one internet transit provider, let's add a second. So what happens when we add a second internet transit provider? Well, the technical people in the room are going to tell me that when you add a second provider, we do it for resiliency. Because if provider one goes down, we still want to have connections to the internet. And that's Absolutely true. That is the reason we buy this second connection to the internet. But what you get when you buy a second connection to the internet is not just resiliency, you also get something called least cost routing. I don't know why the slides headings are chopped off, my apologies. I'm pretty certain they're in the PDF. But let me explain what I mean to you. So if you're at the bottom of the network, you're the customer at the end, and you're buying from one transit provider network, the red network in this context, and you're trying to access a resource on the internet. The red network, in this case, your transit provider, because of how it buys internet transit, is probably going to have multiple ways or multiple paths to get to wherever you're trying to get to, wherever you're trying to get to on the internet. Perhaps there's 5 network hops to get to the resource that you're trying to get to A, and it's, in our example, 7 network hops to get to the resource B. And a very, very rough calculation will tell us that the average length of the internet for our user at the bottom now is 6 network hops away. The internet's a bit more complicated than that, but this is a simplified example. So this is the situation when we have one transit provider. When you add a second transit provider, hopefully your technical team is smart enough to say, well, we want an internet provider that has different routing to what we already have. And to get to the same paths on the internet, the second internet service provider is likely going to have different ways for you to get there. In this case, provider green is 6 hops to get to A and 3 hops to get to B. When you interconnect to multiple service providers, your routers have to start speaking a language called BGP. And one of the things that you get free with BGP, it's built into the algorithm, is prefer the network that has fewer hops away. So without you doing anything, your routers are going to choose these paths to route to the internet. The average length that we get to the resources that we care about on the internet is 4. What am I saying? This is an important concept. This concept that we want to prefer the network that is closer to us. Because in the third installation of what we do as building an internet network, when we have our network set up, or we have multiple transit providers connected, but when we add an exchange point and we're able to peer at the internet exchange point, our network is able to take advantage of the fact that networks that were previously perhaps 5 or 6 hops away are now 1 hop away. And that interconnection, well, that's going to be preferred because it's 1 hop away. Now, again, the BGP speakers in the room are going to tell me, Nishal, AS path is number 6 on the algorithm. This is a simplified example. And in a network where you haven't applied any other metrics to define interconnection, that's how interconnection is going to happen. When you add the internet exchange point, the first exchange point to your economy, everything changes. Because you introduce a low latency, high bandwidth, but high bandwidth preferred path for network operators to suddenly interconnect with each other. And all the things that you were dreaming about, all the things about saying, well, why are my packets taking 80 milliseconds to go from one side of town to the other side of town? All of that drops, all of that becomes, it becomes feasible for you to run other services. It becomes feasible for you to do things like run that VPS or VM service that we were talking about, because suddenly you have the enabling environment to do this. The fourth part of our life cycle is when the networks have grown up. There are multiple internet exchanges in each country. There are multiple exchanges in each city, perhaps. And our network has progressed from being not an internet service provider network where we're connecting end user or retail customers to the network. But when we start connecting, when we progress to become a network service provider network, i.e. when we start connecting other networks to us. So our customers are no longer resale, our customers are wholesale. And that happens when you have the ability to have foreign networks enter your market or more local networks into your market. So many more local networks that the local networks themselves start asking to say, how can we get transport or how can we get bandwidth between our cities from domestic providers? And that's where we want to head to. All of that is nice, but it doesn't explain how we're saving money, right? And that's what we're here to talk about, how to make the network better, how to make the network more cost effective. So let's walk through how a packet would typically flow across the internet. Internet routing, in a well-designed network, networks generally want to do something called hot potato routing. If you think about holding a hot potato in your hand, it's not something that you want to do because it's going to burn your hand. And the idea is that as soon as the potato gets into your hand, you want to move it around and get it out of your hand as quickly as possible. And that's how internet networks like to route. Get the packet out of my network as quickly as possible. So what does that look like in terms of how packets move on the internet? Well, in our simple example, we've got two networks, the red and the green. We've got two customers, the red and the green, that want to exchange information between them. Both networks are connected to multiple redundant transit providers. Both networks are connected to two internet exchanges. Each internet exchange is near, in our example, it just happens to be near one of each network. So how do packets flow when the red customer tries to speak to the green customer? So the red customer has a commercial contract with his internet service provider. He says, I will give you money, and in exchange for me giving you money, please take my packets and deliver it to wherever they need to go on the internet. This is what a normal agreement is, a carrier agreement. So the red customer sends his packet into the red network. Once it's in the red network then has to decide where and how do I send this packet that's destined to the green network. I could send it via my transit providers and eventually it might make its way to the green network. But we just learned that if we're connected at the exchange, then we're one network away, directly connected, and that's what we prefer. So let's send it to the exchange instead. But I've got two exchange points that I could deliver this packet to. Where do I send it? So the red network's faced with, we're human beings, and we tend to be rational. So if you look at this picture, you're immediately going to tell me, well, we're going to send it to IXP1. But routers aren't human, and they don't have intuition. So what drives the network, or what drives the humans that configure the network to want them to choose to get to exchange 1 or exchange 2? In this case, they're going to choose exchange 1, and we'll see why in a minute. So the red network sends a packet to internet exchange 1. At internet exchange 1, the red network is connected to the green network. They exchange routing tables. They happily, the green network happily says, oh, if the packet is meant for my customer, I'm going to pull it all the way down into my network. Once it's in my network, I'm going to deliver it to the green customer. And so far, what we've done is we've managed to take a packet from the red network all the way into the green network. Now, if you've looked at this picture, just looking at it, you might tend to think that the green network is doing a lot more work than the red network. And at the face of it, that's absolutely true, because the green network's link to the internet exchange is a much longer link than the red network's link, right? Now, internet transactions aren't just one way. You aren't just sending information all the time. The green customer has to reply to the red customer. So when the green customer replies, we see the reciprocal relationship happen here. The green customer sends a packet into the green network. The green network now has to decide, how do I reply to the red network? I can choose to send my packets to exchange 2, which is closer to me, or I can send it to IXP1, which is further away. And the green customer chooses to send it to IXP2, which is closer to me. Same thing, the red network goes, the custom packet is meant for my customer. I'm going to draw it all the way up into my network, and I'm going to deliver it to my customer. At the end of the day, the red customer and the green customer have been able to speak to each other and they're happy. And that exercise happens trillions of times every single day across the internet. And that's how a typical internet transaction would work when there's peering. In this example, the red network is responsible for a few things. It's responsible for building its network. It's responsible for building infrastructure to get to its customer, whether that's going to be wireless, 5G, fiber to the home, whatever. I'm going to get money as the red network from my customer. I'm going to take that money and I'm going to invest it in building my equipment, building my infrastructure, building my network, upgrading my backbone, building infrastructure to get connected to the internet exchanges. But the money that I'm spending is money that I'm spending for my network spend. I'm using it to fund and build and grow my network. So the red network becomes responsible for its costs. Similarly, the green network becomes responsible for its costs only, right? They don't cross-subsidize each other. And that's the important thing here, that we have a fair sharing of costs in this scenario. My boss likes to say this. He says, the efficiency of the internet depends upon this principle that for any two parties who want to exchange traffic equitably, there must be a pair of exchanges, one near each party. And that's absolutely accurate. And he does a better way of explaining this particular sentence. But I like to say it like this. I like to say that if you are a country, a city, or an economy that has not yet built an exchange point close to you, then you are always going to be that economy that is exporting your capital elsewhere. What that means is, if you were in a situation like this, where there was no IXP2, you are always going to be the green network. If there's no exchange near you, for you to cost effectively get rid of your traffic, you are going to be building that long circuit to exchange one, which is far away. And, well, if you're going to be building the long circuit, you're always going to be paying more. Because one thing's true in our economy, and that is speed times distance equals cost. And this is the part where I always say, I don't know your environment, so you help me out here. How many of you think the internet is too cheap or too expensive? How many of you are willing to pay more for internet access? Who wants costs to go up? Nobody. You're all shy. You're all asleep. Well, in my experience, except for Barbados, everybody wants costs to come down. Barbados is a special country. If everybody wants costs to come down, then simple arithmetic will tell you that you have to decrease either the speed or the distance. All right, let's try. How many of you think the internet is too fast? Who wants a slower internet? Anybody wants a slower internet? Again, Barbados, but a different country. So if you don't want a slower internet, we can't touch the value for speed. Our customers always want more. And if we can't touch speed, then the only variable that we have to play with is distance. And so if we're looking at reducing cost in the long run, what we have to look at doing is saying, what is it that we're connecting to on the internet? And how can we reduce our distance to it? And a simple way to think about this is that there is no rational way that you could tell me that the fiber distance from Bishkek to, say, Almaty should be more expensive than the fiber distance from Bishkek to London. That's not, I mean, that's crazy. It can't be more expensive. If it is more expensive, then there's a problem. It's not because you're using more fiber. Is it because the cost of labor is incredibly expensive? No. And if it is more expensive, then there's probably something wrong at regulatory environment, at the regulatory level. And that's the thing that we need to push to fix, right? Because if we want to build our regional internet networks, if we want to build this interconnection within our country and the countries surrounding us, then we can't be exporting capital to the UK. We can't be exporting capital to the Netherlands or US, China, Russia, take your pick. So why do we peer? Everything else sounds nice, but fundamentally, we want to not export our capital. Unless you feel that you're a rich country and you're okay with exporting your capital and you've just been sitting here for the last 45 minutes just smiling at me very politely, in which case, thank you. So I'm not finished. The two things that I want to leave you with, and that is, this is what I think should be your goal for CAPERF, and that is to promote that interconnection inside your country and then in the region. Last year, listening to the operators on the, talking to each other, I asked them at the microphone, you've shown me how you're building points of presence. I'm not going to say that word this year. You've shown me how you're building points of presence in Frankfurt, you're building them in Amsterdam, you're building them in Hong Kong. But as a network operator in this region, why are you not building points of presence in the countries next to you? Because that should be what you're doing to drive interconnection between the countries, to drive down costs of interconnection between the countries. So if you're a network operator, last year I asked you the question, you didn't answer it. I'm asking you now because I have the microphone again. What are you doing to build points of presence in other countries surrounding you? Because that should definitely be your goal, right? And the second thing is, what are you doing to promote interconnection between the non-traditional network operators? That we still have this mindset here that peering is something that happens only for internet service providers. And unfortunately, if you were listening to my slides, you've seen I spoke about ISPs a lot. I do that because it's true. This is a model from an internet service provider's perspective, but it's equally true for other organizations as well. If you're a bank or you're a large enterprise, if you're a university and you're hiding in the audience and you're thinking, I am not sure why they sent me to this peering meeting. Well, peering is just as fundamental to your business as it is for an internet service provider. Because everybody likes checklists and everybody wants something to do. When I spoke to you about building infrastructure in other countries, this is actually a more complete list of the things that you want to be able to build and grow within each economy. You'll get the slides, so I'm not going to go through every single one of them, but these are the things that you'd want to have, or what we at PCH calls your infrastructure checklist. This is from an operations perspective. If you're a regulator, you're looking for a regulatory checklist. We took care of you as well. There's a checklist here. But again, this is something that you'll get in the slides. And if you want to talk about it, you'll have my details at the end. So I'm not going to spend much more time talking about that. In the last few minutes, what I do want to talk about is what you can get or what you can hope to get out of CAPERF and how to use the meeting, hopefully to your advantage. And this is really the second part of the newcomers part of it. This meeting is from a different peering forum. It's the African Peering Forum. This was AFCO 5. It was about 2015, I think, in Senegal. And it's one of my favorite pictures still, because there's 3 people from 3 different continents from very different walks of life talking about what we're talking about here, and that's peering and interconnection. If Hisham's listening, you need better pictures for CAPERF, so I can change this for future. There's a researcher, there's somebody who's building commercial networks, and there's an internet exchange point operator in that photograph. And they're all talking about, well, how they can work together to make the internet better. I know all 3 of them, and I know that they did really good work after this conversation. But that's what CAPERF is meant to be for you, and that is what other peering forums are meant to bring to you as well. It's meant to give you that opportunity to be able to find network operators, to be able to find CDNs, to be able to find interested people in peering that can help you navigate and work through what needs to happen to get you connected or answer questions that you might be unclear about, etc. It's that perfect storm for building interconnection, right? That's what a peering forum is. And it works because, frankly, the internet network has decided a long time ago that peering is good for it. I have a friend that says that without data, you are just a monkey with an opinion. So every year, or every 5 years, PCH runs a survey. The URL is at the bottom, and that's the QR code if you want it. Every year we run a survey where every 5 years, sorry, we run a survey where we ask people questions about peering. And as a result of the answers that we've gotten over the years, I think the last survey, we surveyed 19 million peering agreements. 99.98% of the respondents said that for them, peering is as simple as a handshake agreement. And what does that mean? It means that they don't need contracts. They don't need lawyers to get involved. They understand the value of interconnection, and they're happy to do it on the basis of a handshake. Will you peer with me? Sure. And usually it's over email. That's, as I said, that's the URL, 2021. I will be doing one again in 2 years' time, so I hope that folks here contribute to the data as well. The day is full of different things that you're going to experience. Obviously, there are going to be some presentations, but some of the tools that you may not be familiar with that are designed to help people understand who you are and what you want to do. The first of them is called Peering Personals. Peering Personals is basically your chance to get your 1 minute of fame. You get to walk to the microphone, you get to introduce yourself, and you get to say, this is who we are, this is where we peer, and this is where we'd like to peer with you. This is a sample template. The RIPE team have very kindly made a presentation template for you. So if you go to that URL, or if you want to scan the QR code, I don't like QR codes, but I know other people do. So I always write the URL for those people that are like me. You can go to that URL, you can download the peering presentation, peering personals template, fill in your details, your ASN, whom to contact to set up peering, the internet exchanges that you want to peer at, and you can upload it, well, again, at that URL. And the peering personals are happening later today, and there's a session for you tomorrow. So as I said, it's your chance to have your 1 minute of fame, to introduce yourself and tell people why they should peer with you. So here's a sample peering personal slide. Hello, my name is Nishal. I work at Packet Clearinghouse. We're a DNS network, a DNS service provider. We peer at 315 internet exchanges all across the world. This is where we peer. We'd love to peer with you. If you'd like to improve your DNS performance, you definitely want to peer with us. If you are an internet exchange point operator and you'd like to talk to us about having a PCH DNS node, please find me. I will be outside. Thank you very much. That's a peering personal, right? So you each get your 1 minute of fame to do something like this. I didn't follow the template. This is a standard slide I use. The template's slightly different. We are not moving to the next slide. There we go. This year, for the first time, and I'm really happy to see this, CAPIF has peering bilaterals. So this is a dedicated room where you will be able to sit down across somebody that you want to peer with. So let's say you've seen them on stage and you've decided that, hey, I really want to speak to that guy from PCH. You can then set up a session and we can meet at a table like this somewhere and talk about how we can get connected, where we can be peered, and how we can both work to get our meeting, get our network working better. That picture's from Peering Asia last year. This was the quietest that room was in the 3 days that they had the peering forum. So where to get this? Also very exciting, this year, there's a tool called Swap Card. If you haven't registered already, this is a good chance for you to do this. So you can register for a Swap Card account using your registration information, URL and QR code. There's 2 rooms set aside for peering bilaterals, the one-on-one sessions. That'll be this afternoon at, I think, 5:30, and Bahan is likely to provide you with more information. You can register, you can find other people that are registered and look for people that are interesting, that you think you want to talk to, look at people that you think, read their profiles. I always say it's like a dating thing, but it's not quite a dating thing. So, use that as you will. Things that you probably want to do in advance of you getting to these meetings. If you're a network operator, you probably heard about PeeringDB. So you want to make sure you have a PeeringDB account. And if you're going to be sending a meeting request to somebody, then there's a good chance that they're going to look at your PeeringDB account. So make sure your PeeringDB account is up to date. All right. If you don't know about PeeringDB, over the years, it's become the canonical source of network peering information. So networks that are looking to peer with other networks would generally look at PeeringDB and say, are these networks at my at the internet exchanges that I want to get to? And there's lots of tools. If you're a techie, if you search through GitHub or even through PeeringDB, you can find lots of tools to help you find and configure peers. This is what a PeeringDB record would look like. This is the PeeringDB record for PCH. You can see we list the internet exchanges that we're at on the right-hand side, along with contact information, et cetera, et cetera. So hopefully your PeeringDB records are accurate as well. If you're an exchange point operator, or a data center operator, PeeringDB equally applies to you, right? You want to get people into your facilities, and the best way to do that is to make sure that both your exchange, if you're an exchange operator, or your data center, if you're a data center operator, is also listed in PeeringDB, right? If you're an exchange operator, you can also talk to me, or you can go to PCH's IXP directory, and we'll help you get connected to that as well. If you're a network operator, please use an IRR system. I guess the right one is as good as any one for you. It's what you pay for already, so it's good for you to use that. It really helps both exchanges and network operators when we have to create and modify filters for you. There's lots and lots of ways to automate it these days. I've just chosen one. So for example, I took PCH's AS object. And if I was going to automate, I would run a simple tool like BGP4, which is a downloadable script. And this is a quick and easy way for me to generate the filters. I'm only showing a portion of the set here. But it's trivial to build this into any kind of automation system. I'm saying this because there's more and more, there's two things, right? People are going to tell you that it's difficult to set up BGP and it's difficult to do this, and network operators are going to say it's complicated, and technical people have lots of good reasons sometimes for not wanting to do things. It's really not difficult. It's much easier now than it used to be 30 years ago. There are better tools, there's a better ecosystem, and there's a lot of folk that are willing to spend time to help and support get this off the ground. And second, security is becoming key to a lot of what we're doing these days. So if you're going to be worried about peering, and you're worried that, oh, I've heard about route leaks, I've heard about route hijacks, how am I going to make sure that my peering stays safe? And these are excellent ways to do it. More tips, please set up a peering at email. Don't have people contact a single person for a peering, because that just doesn't look professional and it doesn't help you when people have moved on. So make sure that person.name at your domain is not the contact for peering anymore. And finally, this is really what we want to build, right? This is the magic that we're all looking for. That local content on local hosting, accessible via local internet exchange points, that magic gap in the middle, that ikigai, it's the thing that we want to get built. Because if you don't do this, any part of you not doing this means that you're exporting capital. It means that money is leaving your economy to somewhere else. And I really hope that that's not your future. So thank you for listening to, this is the email address if you have queries for the RIPE team. But thank you for listening to me. I hope you've learned something. And I will be around for the next 2 days if you would like to talk to me. I speak no Russian, but I'm willing to try. Thank you very much. I think we have a few minutes for questions, if there are any. No questions? Okay, well, I think there are no questions, but if you do have questions, again, please feel free to come find me in the hall. I'm very happy to talk to you. If you're interested in building exchange points, if you want to know more about how they work across the world, this is really the thing I do. And I'm happy to talk to all of you. Thank you. Svesta.